So I'm doing a presentation today of wine quality prediction, and so in this presentation I will explain on how I reached on the results. So first of all, we are introducing the red wine quality dataset, of which we are provided with a dataset of red wine samples, and the goal of the activity was to find the model wine quality which was based on physiochemical properties, which is X1 to to X5. So variables of interest, we have X1, which is citric acid, we have X2, which is chlorides, we have X3, which is total sulfur dioxide, we have X4, which is a pH level, we have X5, which is alcohol, and then against Y quality, which the score is supposed to be between 0 to 10. So the data subset for analysis. For this analysis, a random data set of 406 samples was selected using set.seed, which is my student ID 223721615 for reproducibility. The focus was on manageable dataset for initial modeling. And from this, so from this, we can see that we had some histograms we generated, and the histogram distribution explanation. Looking at the distribution of my physiochemical properties, I observe a variety of patterns. First of all, we have the citric acid shows a tendency towards the lower levels with a positive skew. We have chlorides are overwhelmingly concentrated at very low values, exhibiting a strong positive skew with few wines having higher concentrations. We have the total sulfur dioxide, which I observed that it's also high right skewed, with most wine having lower levels and a tail extending to higher values. We have pH, which appears to be most symmetrical and distributed, centered around a slightly acidic range. Also, we have the alcohol content shows a slight positive skew, with most wines falling in the moderate range. Finally, the quality scores in our sample, which I carried out, are concentrated around the middle values of 5 and 6, suggesting a central tendency in the perceived quality within this subset. So the scatter plots each which is X variable against Y quality. So the screenshot I took from my RStudio after running the code, these are the screenshots. So I will provide the code and you run the code as a lecture, and the results will come through, and this is what you will see. This is the overview of the screenshot. So the scatter plots description. So the scatter plots revealed generally weak linear relationship between the individual physiochemical properties, which is the citric acid, chlorides, total sulfur dioxide, and the pH and the wine quality. So while alcohol shows a slight tendency towards higher quality with increasing levels, the other variables do not exhibit clear linear trends. This suggests that wine quality is likely influenced by more complex non-linear interactions. So data transformation selection of variables. So 4 predictor variables were selected for modeling, which is X1, the citric acid, X2, the chlorides, X4, pH, and X5, alcohol. The target variable is Y, which is the quality. So the data transformation, which is a power transformation. A power transformation of the p value, which is 0.5 square root, was applied to the selected 4 predictor variables and the quality variable. So the rationale, to potentially reduce the impact of skewness observed in variables like chlorides and to explore the nonlinear relationships. So the data transformation min-max normalization. Following the power transformation, min-max normalization was applied to scale all transform variables to the range of 0 to 1. The purpose for this was to ensure all variables have a similar scale before aggregation, preventing variables with larger initial ranges from dominating the aggregation process. The model building aggregation function. The following weighted aggregation functions were fitted to the mode transform data. So what I did, we were supposed to find the weight arithmetic mean, which is WAM, the weight power mean, WPM, with a value of 0.5, the weighted power mean, WPM, with a power of 2, the order weighted average, averaging OWA. And so the model summary weights and parameters. So after carrying out my results, these were the results which came. WAM was 0.9, 0.05, 0.00, 0.201, 0.290, and so these are the respective results. And the WPM, the value was 0.5, 0.51, 0.00, 0.235, 0.234 respectively. The WPM, which is power of 2, which is 0.146, 0.00, 0.244, 0.6. And the OWA, the values were 0.00, 0.188, 0.242, 0.570 respectively. So these were the weights which I acquired earlier, or so the importance of the variables. So on this occasion, so the WAM, the citric acid has the highest weight, suggesting it's important influential predictor. According to this model, chlorides received a weight of 0, indicating it has no direct impact in this linear weighted average. The WPMP is equal to 0.5, similar to WM. Citric acid has the highest weight. The WPM, which is 2, alcohol has the highest weight, suggesting a stronger nonlinear relationship captured by this power. Citric acid has a lower weight compared to the others. Alcohol has the highest weight, but the OWA considers the rank of the input variables rather than the magnitude. The 0 weight for the citric acid in this specific is notable. So the best fitting model, based on the performance metrics in table 1, which I showed before, the weight arithmetic mean WM exhibit the lowest MSE 0.025 and RMSE 0.158, and the highest correlation coefficient of 0.621 on the training data. Therefore, the WAM appears to be the best fitting model for these selected data among the tested aggregation functions. So the prediction results. So the new input citric acid 0.8, chloride 0.63, pH 2.51, alcohol 7.0, transformed and normalized. Predicted quality using the WAM model approximately 0.14 after average transformation, rounded to the nearest integer, which is 0. So on these, the predicted quality is very low. This suggests that this specific combination of transformed and scale physiochemical properties associated with the low quality according to the WAM model trained on a subset. The unusually low pH value in the input might be a significant contributing factor based on the model's land weights. Implication or limitation of the WAM model. So on this, I found out that the implication, the WAM model provides a simple way to combine the influence of different physiochemical properties on wine quality with land weights, indicating their relative importance within a linear framework. Limitations. The model assumes a linear additive relationship between the variables, which might not fully capture the complex interaction in wine quality. It is based on a subset of the data and only 4 variables, potentially missing important information. The low prediction for the new data point suggests potential limitations in the model's generation ability or sensitivity to extreme input values like the low pH. So the professional ethics and potential data privacy issues. So the professional ethics on this case, there's transparency in the modeling process, acknowledging limitation and avoiding interpretation of results are crucial. The model should not be presented as a definitive predictor of wine quality. On the data privacy, while this dataset is public, in real-world applications with proprietary wine data, strict data privacy measures would be necessary to protect sensitive information about vineyards, production processes and quality assessment, and normalization and secure data handling be